Hello students, today we're going to learn section 1.4, building functions from functions. First of all, a composite function is a function within a function. Again, a composite function is a function within a function. Now there's two ways to write a composite function. It's this symbol f, composite g of x, or f of g of x. So the way to state this composite function is f of g of x. F of g of x. These two expressions mean the same thing, composite functions. I prefer composite functions to be written in this way. Alright, when we evaluate composite functions, think inside first. Again, think inside first. So here is example 1. There are three parts to this. They want us to find f of g of 4. So what we're going to have to do is we take a look at our function. F is x squared minus 1. The g function is 2x minus 3. So f of g of 4, again, I prefer to write it this way versus this way. So f of g of 4, think inside function first. The inside function is the g function. So I'm going to evaluate g of 4. I'm going to put 4 wherever I see an x in our g function. So the next line I write is 2 times 4 minus 3. Again, we substitute the 4 wherever I see an x in our g function. So 4 goes in here. So that's 2 times 4 minus 3. When we simplify this, that's what? 8 minus 3 is 5. So now we deal with the outside function. So f of 5. So now we use the f function. Substitute 5 wherever we see an x in our f function. So this is now 5 squared minus 1. So 5 goes wherever I see an x in the f function. So 5 squared minus 1. So f of g of 4 equals 24. Again, think inside first. Next, let's find g of f of 4. So think inside first. So the inside function here is f, our f function. So I'm going to substitute 4 wherever I see an x in our f function. So here is the f function. It's in here. So this is x squared minus 1. They want us to evaluate f of 4. So 4 goes in our x. So 4 squared minus 1. 4 squared minus 1 is 15. Now we're done evaluating the inside function. Now we'll evaluate the outside function. So the outside function is our g function. So I'm going to substitute 15 wherever I see an x in our g function. So 15 will go in here. So this is now 2 times 15 minus 3. Simplify that and you get 27. So g of f of 4 equals 27. Last one is we have f of 4. So our inside function is f. We're going to substitute 4 wherever I see an x in the f function. So 4 is going to go in here. So this is now 4 squared minus 1. F of 4 equals 4 squared minus 1. Evaluate this. That's going to be 15. Now we're done evaluating the inside function. Let's evaluate the outside function. The outside function is f. So I'm going to substitute 15 wherever we see an x in our f function. So this is going to be now 15 squared minus 1. So 225 minus 1 is 224. So f of f of 4 is equal to 224. Alright, so example 1, we evaluated composite functions with a constant. In example 2, we're going to evaluate composite functions with a variable here. After that, we're going to state the domain. Okay, so the first thing we're going to do is let's go over f of g of x. So when we do this problem, we do our inside function first. Our inside function first is g of x. So what does g of x equal? It equals the square root of x. Well, and that's all we do. We substitute whatever g of x is. G of x is square root of x. So I substitute. We're done with the g function, the inside function. Let's do the outside function. The outside function is our f function. So now we substitute whatever this is back into our f function wherever we see an x. So I'm going to replace the square root of x wherever I see an x. So f of the square root of x, so substitute this here, substitute this here. So the square root of x squared minus 1, we substituted. So the square root of x squared, this will undo that, and now we're just left with x minus 1. So f of g of x equals x minus 1. I showed you a different way how to look at this because it gets confusing when we just see variables. So that's why I did this extra step to show you how I got here. Now, if I did it the way we did example 1, this is similar to example 1. G function is inside, so square root of x, g of x equals the square root of x. Do the outside function. Substitute this wherever I see an x in our f function. So now this here, we substitute square root of x here. So that's square root of x squared minus 1, and we get the same result. So f of g of x equals x minus 1. Since we don't have any more radicals or we don't have any variables in the denominator, the domain for the composite function is negative infinity to infinity, meaning all real numbers will work. Okay. So now we look at our g of f of x. So I'm going to show you again, inside function first, f of x is x squared minus 1. Now we'll do the outside function. The outside function is our g function. Substitute x squared minus 1 wherever I see an x. So this radical will still be there. And then it's now substitute this wherever I see an x. So x squared minus 1 replaces x. And there's nothing else we can do. So g of f of x equals the square root of x squared minus 1. Now this will not undo this because this is the square root of x squared minus 1. This minus 1 is attached to all this. That's why we cannot eliminate the radical. The domain has to be greater than or equal to 0. So here's how to find the domain. X greater than or equal to 1 or x less than or equal to negative 1. So here's the domain in interval notation. Negative infinity to negative 1 including negative 1. Union with 1 to infinity including 1. So this is the domain. This method is similar to what we did in example 1. Inside function first. F of x is equal to x squared minus 1. We're done with the inside function. Now we'll evaluate the outside function. The outside function is our g function. So I'm going to replace whatever's in here for x. So it's the square root of, well, x squared minus 1 replaces for x. So we can't simplify. So g of f of x equals the square root of x squared minus 1. So in example 2, there were 2 ways I showed you how to get to the result. All right, have a good day.